ننتقل الآن إلى question or part 10 in the exam. In this part we will convert angle measurements between degrees and radians. This is a very simple part. طبعا this table we have to memorize. It's very important. It's extremely important to memorize this table in order to convert from degrees to radians or radians to degrees, or from degrees to revolutions or revolutions to degrees, and from radians to revolutions or from revolutions to radians. Let's take the following question. Question 32. بحكي لنا one complete revolutions which is equal to 360 degree is the same as. طبعا معطينا كل الأجوبة بالراديانس, so we want to find or we want to convert this value from degrees to radians. How to convert from degrees to radians? If we go back to the table, to convert from degrees to radians, we multiply the angle that we have by pi divided by 180. طبعا why do we want to convert to radians? Because all of the answers are given in radians. So how to do that? We will say the given value, which is 360, multiplied by pi divided by 180, and this will be cancelled. This is 1, this is 2, and the answer is 2 pi. Of course, in radians. So the answer is D. Very simple. Let's highlight it. Question 33. Convert 3 revolutions into degrees. Convert 4/3 pi radians to revolutions, and convert 225 degrees to revolutions. Let's start with the first one. To convert from revolutions to degrees, we just multiply by 360. So we will say this is equal to 3 times 360. That is equivalent to 1080 degrees. Right. What about converting from radians to revolutions? Again, we divide by 2 pi. So we say 4/3 pi divided by 2 pi. And this will cancel this, and this will go down. So we get basically 4/6, which is equivalent to 2/3, or 0.67 revolutions. Both or all of them are the same. Finally, how to convert degrees to revolutions? Again, in this case, we have to divide by 360. So 225 divided by 360, which will give us 0.625 revolutions. Let's go now to part 11 in the exam. In this part, we will sketch the path taken in circular motion, uniform and non-uniform, and explain the velocity and acceleration vectors, magnitudes and directions during this motion. طبعا ذكرنا مسبقا بأنه if we have 3 different cases, in the case 1 we have a positive angular acceleration, then we have 2 components for the acceleration itself, the tangential acceleration and the radial acceleration, which is the centripetal acceleration. And the magnitude or the acceleration itself will be between both. But what if alpha is equal to 0? That means we only have one acceleration, which is the centripetal acceleration. Please remember that even if the object is moving with a constant speed, a sub c does not equal to 0. Why? Because the centripetal acceleration AC is equal to what? It's equal to v square over r. Of course, the object is moving. And what keeps the object moving in a circular path actually? It's the centripetal acceleration. So we should know that. And the direction of the centripetal acceleration is always towards the center of rotation. But what about the tangential acceleration? It is always tangential, or as a tangent. We draw a tangent to the circular path at the point of interest. Right. The final case we have if the angular acceleration is negative and less than 0. In this case, if the object is moving in this direction, for example, this is the direction of the velocity vector, then the tangential acceleration will be in the opposite direction. Why? Because it's slowing down. It's slowing down. But the centripetal acceleration, as I told you before, is always towards the center of rotation. ننتقل الآن إلى بعض الأسئلة. Question 34 بيحكي لنا الآن a rock attached to a string moves clockwise in a uniform circular motion. In which direction from point A is the rock thrown off when the string is cut? طبعا where is point A? This is point A. at this point, where would the rock move? Of course, it will move downward. So we will choose D. Then, sorry, D. So the answer is D. But what if actually, if, for example, in this question, they asked us to know the direction of the motion of the stone at this point. Since it's moving clockwise direction, it will move to the right. But what about this point? It will move upward. But what about this point? It will move to the left. And finally, at point A, of course, it will move downward. لو كان عندنا الستون بتتحرك counter clockwise بنعكس كل شيء. نعكس كل الكلام. طيب. Let's take a look at question 35. Consider an object that moves in a circular path at constant speed. When it reaches point A, which of the following describes that direction of its centripetal acceleration and velocity v? طبعا, this is the direction of motion, and this is the point A. Of course, the direction of the velocity will be tangential to this point, and in this direction. Or let's draw it in a better way, sorry. Let's use arrows. I think it will be clearer. So this is V, and we also have the centripetal acceleration towards the center of rotation. So basically now, you can say that this is V, and this is A sub C. طبعا, which answer coincides with those is basically D. So we choose D. تمام. Now, in part 12 in the exam, here we will identify that for an object in circular motion with a given angular velocity, the centripetal force increases with the distance from the center. طبعا, I derived an equation for you just to understand the relationship between the centripetal force and, first of all, the mass, the radius of rotation, and the time period. الآن, the relationship between the centripetal force and the period of rotation or time period, they are both inversely proportional to each other. So Fc is inversely proportional to the square of T, while the centripetal force is directly proportional to R. And also the centripetal force is directly proportional to M. So we use always this equation to know what is the relationship between R, T, M, and centripetal force. Let's take question 36. And here, it says which piece would fall first as the angular speed of the spinning table increases. طبعا, as the spinning or the angular speed of the spinning table increases, that means what? That means the further the part from the center of rotation, the more friction we need for or just to keep this particle from skidding away or from moving away from the disk. فبالتالي, the furthest the point or the furthest the part is, the more friction force we need to keep it in its place. فبالتالي, at certain point, we know that the friction force has a certain value, or the static friction has a certain value. It can be maybe, let's say, 10 newtons. And as we keep increasing the angular speed, this value will be constant, لكن the centripetal force will have to increase to keep it in that way. ليش? In this case, F sub C is equal to the friction or the static friction. Like this value is constant. So as we keep increasing omega, the centripetal force has to be a certain value. لكن we cannot keep up with this value. فبالتالي, basically, باختصار يعني, the further the part from the center of rotation, the more centripetal force to keep it in its place. فبالتالي, the first one that will skid away is basically the red particle. So we choose this one. صار الكلام يعني, كل ما كانت النقطة أبعد, كل ما كان أصعب إن نحافظ عليها في المسار الدائري, فبالتالي راح تكون عندنا أول جزء أو أول جسم بخرج للخارج. طيب. نيجي الآن إلى question 37. Question 37, this is a solved problem in the book. بحكي لنا الآن في هذا السؤال. Suppose that cars move through the U-turn shown in the figure at constant speed, and that the coefficient of static friction between the tires and the road is mu s equals to 1.2. if the radius of the inner curve shown in the figure is RB equals to 10.3 meters and the radius of outer radius is RA equals to 32.2 meters and the cars move at their maximum speed, how much time will it take to move from point A to A prime and from point B to B prime? Right. First of all, we should know that time is equal to the distance divided by the velocity. الآن, in this case, we have two times to calculate. We have the time for the red path and time for the blue path. So we need to find the time for the red path, which is equal to the distance covered in the red path, divided by the velocity of the car in the red path. And we also have to find T sub blue, which is equal to the distance in the blue path. So this is blue divided by V blue. Come on, let's keep it consistent. B capital. Oh, sorry. This is blue. And we can say this is R capital, just to keep it consistent. Right. Now, how to find those values? First of all, we have to find the velocity and the distance covered by both cars. Let's start with the velocity. Let's say that, أولاً, in this case, if we go back to this free body diagram, if you go back to my videos that I went through in my YouTube channel, we have basically derived an equation for any car that negotiates a curve, and this curve has to have a flat surface. So this is basically a flat surface, and there is a vehicle that is negotiating this curve. In that case, we have an equation that we can always use. Like, what is that equation? It's V, and for example, for the red path, is equal to the square root of, and this is equal to R times mu S times G. My advice for you actually to memorize this equation. V is equal to the square root of R, which is the radius of a circular path, times the coefficient of static friction multiplied by the gravitational acceleration. This will make your life easier. طبعا, if you want to know how we have derived this equation, just go back to my YouTube channel and go start from lesson 9.5, 9.6 and 9.7 just to get the idea. Right. Now, since we have V sub red, we want to find the velocity at the red track. So this R has to be for the red track. So this is red capital, sorry. We can fix this problem. This is R capital. Right. So in this case, we will just substitute the values. What is R capital for the red track? It is basically RA. So instead of actually writing R red, let's write it RA just to keep it consistent. What is this value? It's given as 32.2 meters here in the question. This is it. Right. Multiplied by the coefficient of static friction, which is equal to 1.2, multiplied by, now the value of G is 9.81. And the answer for this is 19.47 meters per second. Right. What about the velocity of the car in the blue path? It will equal to the same equation. Like now we will substitute R sub B for the blue track, US times G. And this is equal to the square root of, now this is equal to 10.3, this is RB multiplied by 1.2, the coefficient of static friction, multiplied by 9.8, the gravitational acceleration, and this will give us 11.01 meter per second. Now we need to find the cover distance by or in the blue path and the red path to go from A to A prime and from B to B prime. So let's start with D red, for example. D for the red is basically equal to half of the perimeter of the circle that we can draw from that arc. So basically, instead of writing 2 pi r to find the perimeter of a circle, we have half circle. فبالتالي we say what? only pi times r. Which radius? We have r sub a. So we say RA. And that is equal to pi times 32.2. This answer is equal to 101.47 meters. طيب الآن بالنسبة للجزء الثاني we want to find d sub blue. Keep forgetting that this is R capital, sorry. So d blue is equal to, now this part consists of two things. We have this line, straight line going in this direction, so this one here, and we have this line in this direction. Adding to those, we have to add the perimeter of a half of a circle. So this is the perimeter we have to add. So how to find this total path? This total path is equal to, first of all, to, instead of writing 2 pi r, we will just say pi r, which is the perimeter of a half of a circle. Which r? It's r sub b. Plus, we have to find those two lines, basically. How to find them? It's basically the radius of this part, which is RA, minus RB. So this is RA, and this is RB. So if we subtract both values from each other, what do we get? We get this distance from this point to this point. This is what we find, which is RA minus RB. So now we write down here, since we have two lines, we will write 2 times RA minus RB. So we plug in the values, just plug in the values. Pi times RB is 10.3 plus 2 times 32.2 ناقص or minus 10.3. So the answer for this, of course, will give us, I think, around 76.16. So let's write it down here. 76.16, and the unit, of course, in meters. Now we go back to the main equation to find the time. So first of all, let's start with the first one. T red is equal to D red. We found it to be 101.47 divided by V red, which is equal to 19.47. So this is the value, and this is the value that we have just substituted. So the answer for this will be around 5.21 seconds. And if we go now to the blue part, so we say T blue, it's equal to. Now, first of all, we substitute this value, which is D blue, 76.16 divided by, then we divide it by V blue, which is 11.01. And the answer for this will be 6.92. And of course, the answer is in seconds. And this is the end for this question, or the end of this question. طيب. نيجي الآن إلى part 14. In this part, we will distinguish between tangential acceleration and radial acceleration and specifying the cause and direction of each. جميل. طبعا, this is basically, I made this question short. This is the ultra-centrifuge question we have in the book, but the statement of the problem is very long, so I made it just short. شو بيحكينا في هذا السؤال? Calculate the required frequency and the linear speed of a sample in an ultracentrifuge. The sample is subjected to a centripetal acceleration of 840,000 g at a distance of 23.5 centimeters from the ultracentrifuge's rotation axis. By the way, in my YouTube channel, I think I just ما بعرف, يمكن عملت تقريب زيادة عن اللزوم, طلع عندي الجواب شوي مختلف. But I'll give you the exact number that we have in the book and the exact number that we should get by solving this problem. Right. So first of all, we are given the centripetal acceleration as 840,000 g, which is equal to 9.81. And the answer of this is 8.24 times 10 to the power 6 meters per second square. And the radius of rotation is given as 23.5 centimeters. We just convert it to meters, which is equal to 0.235 meters. Now, let's write down the equation of the centripetal acceleration. A sub c is equal to what? It's either omega square Vr or V square over R. Since we need to find the frequency, and we know that omega is equal to 2 pi f, so we will use this form, omega square times R. And then on the right side here, we will write down omega is equal to 2 pi f, and then we find an equation for the frequency. What is the frequency? Since we need to find it, it's equal to 2 omega divided by 2 pi. Nice. Now we just plug in the values that we find from this part into this equation. Or we can substitute this value here in the main equation to find a relationship for the frequency. We can do that. Let's make it simple. We just remove this. So again, we go back to this equation. We find omega by plugging the values that we've got from the problem itself. A is equal to 8.24 times 10 to the power 6. And this is equal to omega square times R, which is 0.235. Again, I solved this problem in a different way in my YouTube channel. Both are correct, actually. Both are correct. If you would like to memorize that relationship that we derived in my YouTube channel, that's fine also. Right. So once we do shift solve for this, we get omega equals 5,921.47 radians per second. And then we go back to this equation here to find the value of the frequency. We say frequency is equal to 5,921.47 divided by 2 pi. And of course, the answer for this will be, I think, it's 942. It's 942.43 hertz. Right. Now, also we have to find the linear speed. So we will say that, let's use another color. And say that this is A basically. So B, the linear speed V is equal to omega times R. So plugging the values in, we have 5,921.47 multiplied by the radius of rotation, which is 0.235, will give us V equals to 1,391.6 meters per second. And this is the end of this question. Now let's go to question 39. In question 39, it's similar to the previous question. In a centrifuge or a centrifuge in medical laboratory rotates at an angular speed of 3,600 RPM, which is revolutions per minute. When switched off, it rotates 60 times before coming to rest. Find the constant angular acceleration of the centrifuge. First of all, we have to find the initial angular velocity at which it rotates. So omega naught is equal to 3,600. And how to convert from revolutions per minute to radians per second? Again, multiply by pi over 30, or 2 pi over 60, which gives you pi over 30. And the answer of this is 377 per second. It says that it comes to a complete stop. So basically, this value is omega naught. What is omega final? Omega final is equal to 0, because it comes to complete stop, to rest. How many revolutions it makes? It makes 60 revolutions. So we have to find also delta theta in radians. How to do that? We just say 60 multiplied by 2 pi, which is equal to around 377 radians. Now to find, of course, we need to find alpha. We have omega naught, omega final, and delta theta, so we better use this equation. Say that omega is equal to omega square, omega naught square plus 2 times alpha times delta theta. Okay, now we plug in the values. What is the final angular speed? It's equal to 0. So we say this is equal to 0 equals to 377 square plus 2 times alpha times delta theta, which is 377. Now we do shift solve. Once we do the shift solve, get that alpha is equal to negative 188.5 radians per second square. Again, why the value is negative? Because it's slowing down, it's coming to a rest. راح توقف. فبالتالي we should know that alpha is equal to negative 188.5. And this is the end of this question.